And welcome everybody to the Daily Space Weather Show. We've got some spectacular imagery coming at you tonight, as you may have come to expect from the Smash News Network least busted name in news. These are the past 24 hours from SDO. And if you're looking for a closer look, we'll get real close. Of course, this new massive sunspot group here is not all that exciting. A great example of how a large sunspot doesn't necessarily equate to large solar flares. So it is a beta-class sunspot group. It does have both polarity umbrae, but not a lot of complexity in terms of the magnetic shear. There's an extreme close-up. That's actually 304 plus 171 angstroms running 60-minute difference imagery. And before we move on to other stuff, let's take a look at what's going on planet Earth for a brief moment here. These are the earthquakes that are erupting: Abiko, Suinose, Jima, Ibu. Also Luitolo there. Some gas-poor lava there coming out of the southern slope of the 2020 cinder cone. Semaru also erupting. Shishaldin also erupting. Actually lowered the level to yellow for Shishaldin. Popocatépetl, Revenador, and Sabancaya all erupting. Next, our earthquake report. There are the past 90 days. As we see a 7 magnitude earthquake drought going on here, folks. It's been a while since a 7 magnitude quake, which means we are a bit overdue. So pay attention to the western plate boundary of North America, where it butts up against the Pacific plate. Let's see the quakes of a 5 and greater magnitude for the past 24 hours. So this is interesting. We had a 5.1 at Papua New Guinea, and then only 4 minutes later a 5.1 at Peru on the other side of the Pacific Ocean. That's pretty interesting. Also, Timor-Leste had a 5.0. And then Pakistan had a 5.2. And then only less than 20 minutes later, a 5.1 at Peru. So remember, folks, any earthquake can be a foreshock. South Sandwich Islands region had a 5.1 at 18:01 Universal Time this evening. And let's get back to space, since there is plenty to cover when it comes to space. So the 10.7 centimeter radio flux now down in the 150s. There's a 1-year graph. The radio flux is the black line. The red line is the sunspot number. And here's a Space Weather Enthusiast dashboard. 152 solar flux units is the 10.7 centimeter radio flux. So there you go. And no space weather storms here in the forecast by NOAA. And I would tend to agree there, although there may be one minor CME impact showing up sometime after midday on the 21st, not likely to cause a geomagnetic storm. Anyway, these are the past 4 hours of Earth's magnetic moment from space. And we did have a minor CME impact here. Well, it's minor so far. It's not accompanied by any strong magnetic fields, but we did see a big uptick in the solar wind density here, which we'll get to momentarily. A big uptick in the solar wind density showing up at the Discover, but not at the ACE. So a filament passing its way through the local region. Next, the last 4 hours of Earth's magnetic moment from the ground level. Our ground magnetic perturbations map. So right at the end, you'll see a little bit of an uptick there as some higher density solar wind arrives. It's pretty minor. KP index currently at 0. KP 0, folks. It is extremely geomagnetically calm. And next, the real-time solar wind. So the Discover showing an incredibly slow, the ACE showing an incredibly slow solar wind there. Less than 300 kilometers per second. And less than 4 protons per cubic centimeter. But let's look at the Discover. That's where the exciting stuff's going on. A big uptick in the solar wind density there, up to nearly 40 protons per cubic centimeter. So about 7 times as many protons there showing up than were just there a few hours ago. Looks like a little CME impact. 38 protons per cubic centimeter is the current solar wind density. Solar wind velocity here still much faster than the ACE at the Discover, showing 385 kilometers per second. GOES magnetometers are relatively smooth. We're seeing a little bit higher lows. Besides that, nothing exciting going on in the geosynchronous near equatorial orbits of the GOES. They're located at like 24,500 miles of altitude in the outer portion of the outer Van Allen belt. Next, our top view ecliptic plane field plot. As Earth remains in a South Pole magnetic sector, getting right toward the middle of that South Pole magnetic sector depicted there in red. Here's our line of sight field plot. Which brings us to our coronal hole line of sight plot. And we are seeing coronal holes in the eastern limb there, or the eastern quadrant, getting more defined as we forecasted yesterday. Some coronal holes rotating in, and these will be geo-effective, assuming they don't close up before they're in the Earth-facing portion of the solar disk. So that's the situation from the National National Solar Observatory. Here is SDO for today, February 19th. Don't judge a star by the color of its corona. Judge a star by the content of its chromosphere, or perhaps photosphere. That's 211 angstroms there from the SDO, the Solar Dynamics Observatory. Continuing right along to sunspots. Again, sunspot number, like yesterday, continues to decline here, folks. It's now gone. It's below 100. So for those of you who are frightened of a low activity sun, it's time for you to stay in the bunker. And high activity sun people, you can stay out of the bunker. Current sunspot number is at 75, approximately 75 sunspots. Next, flare probability monitor and scoreboard. And the likelihood of large solar flares is not all that high. Interestingly enough, you can see the monitor going up real high here, but I'm not exactly sure why that is. I'm not seeing the magnetic shear that you would expect to see for a forecast of major flares, but maybe I missed something, so we'll take a look. We'll even look at the magnetic fields. There's the SDO continuum. And there are the magnetic fields. I mean, we do have this, like, leading umbra down here. That does create a little bit of magnetic shear, but that's not looking like a big flare player to me. If you agree, disagree, or have no opinion at all, make sure you let us know in the comments. So there's an extreme close-up of that sunspot 3590. I initially thought it was going to be 2 sunspots, but I'm pretty sure that's just one. You've got a North Pole umbra in the lead and a South Pole umbra trailing, and the trailing sunspot is looking pretty weak. So anyway, let's move on to, how about solar energetic particles? SEPs are returning to a baseline level. The likelihood of an SEP, of additional SEPs, really is kind of declining at the moment. And as far as solar flaring, it's been pretty minor. Only C-class intensifications for the past 24 hours, like a C5 and a quarter and a C5, about a C6. I don't know. Pretty weak solar flaring, though. It's all been coming out of the northeastern limb, that new sunspot. So let's take a look at how about the SDO. There's 94 plus 131 angstroms. So I don't know. The likelihood of an X-class flare, I think, is much lower than what the flare probability monitor and scoreboard are showing. But hey, that's just me. Here we've got 131 angstroms along with the 60-minute running difference of that same wavelength. Again, there still is a possibility of large flares in that northwestern limb, which would be your upper right. And there is still some possibility of a large flare up there in your upper left, the northeastern limb. Yes, we've got extreme close-ups, as you may have come to expect from the channel. These are all 24-hour videos from Solar Dynamics Observatory depicting ionized iron. 131 is the hottest wavelength. It's great at showing magnetic filament lines as well as active regions and solar flares. Great view there of those new sunspot groups. And let's move on to some more stuff, such as a star chart. So there's our star chart. That's what's going on over our head. That's Lehigh Valley, Pennsylvania. If you're up looking at the early night sky, you might see a setting Saturn and Jupiter and the moon up there higher on the ecliptic. Next, a solar system forecast. Here's your 1-week forecast for heavenly bodies. As this side of the solar system is becoming increasingly lonely, check it out, folks. No planets on this side of the solar system except for Earth. They're all on the opposite side. Next, our astronomy photo of the day. And this one is a video from Parker Solar Probe. I'll play a little clip for you here. And you're seeing the solar wind here as the Parker Solar Probe's side viewing camera shows those filaments there. And you're seeing the plane of the Milky Way galaxy as well as multiple planets showing up. Parker Solar Probe, the fastest object ever built by mankind. apod.nasa.gov is where to check it out. And there's Jupiter passing by. And let's move on to CMEs. So CMEs have been pretty mild since yesterday. There's one out of the north-northeast, and that's about all that's happened. Did I just see a comet? Let's let that play through one more time. No, I didn't. No, I didn't see a comet. Anyway, here's the C3 as well. And if you're wondering what planet that is the planet Mercury. Yes, Mercury. So there's LASCO C2 and C3. Not very exciting as far as CMEs, coronal mass ejections, when the sun blasts off portions of its atmosphere into the greater solar system. We'll take a brief look at stereo A and its difference imagery also. There's stereo A's coronagraph. Difference imagery on the right, the raw coronagraph on the left. Those are not earthly directed coronal mass ejections. Let's take a look at our custom videos here. And we'll pull way in. Here we've added the 193 angstroms difference imagery to add a little bit of contrast there in showing plasma filaments. There's the full zoom. And let's take a couple more looks at these new sunspots. Really, it's just one sunspot group, Sunspot 3590. Not bad. And there's the full zoom. And let's move on to bonus features, but first, plasma filaments. So they've been known to turn into CMEs. And there are quite a lot of them on the Earth-facing portion of the solar disk there. Also some prominences both in the east and in the west. So there's a last image. Let's count filaments briefly. That's 1. There's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. About a dozen filaments on the Earth side of the disk. Quite a bit of filaments. And the last feature before we get to bonus features is the GOES 16. You can see a big prominence there associated with those setting sunspot groups in the northwest. And let's move on to bonus features. So first is satellite charging hazards. We show that because if there are any interferences going on with the weather satellites, you might know why. It's not going to happen today. We don't have any charging hazards. It's smooth sailing. The GOES electron flux here, kind of low. It's been an ongoing electron shortage. There's the 1-year graph. You can see this extended period there going all the way back into December with very low levels of electron flux. Solon.info is where to check that out if you want to see it yourself. There's the forecast model. And the electrons here are a bit higher than NOAA's forecast. And yeah, it looks like a bad forecast. So next we'll show the layer where it's measured, the F layer. Feel free to pause the video on this frame if you're not familiar with temperature of atmospheric layers, electromagnetic radiation penetration, and chemical concentrations. Here is the F layer of the ionosphere. And it is pretty nominal here at the moment. Nothing very exciting going on. We're not expecting any major fireworks from that little bit of higher density plasma that we saw arriving. Not a lot expected to be going on at about 300 kilometers of altitude. The layer of the level of the F layer, that's the anomaly in megahertz from a 30-day median. We'll also show the global ionosphere nowcast depicting total electron content on the left and maximum usable frequency on the right. For you GPS and radar and radio operators there, that may help you. We'll close out with the latest high-res imagery. So we'll just take a brief look at this. And it is not all that magnetically complex. It's beta-gamma class. It's still a little bit tough to tell because it's so close to the limb. I think it's beta-gamma class. Yeah, it's beta-gamma class, but I don't think it's beta-gamma delta class. Oh, there might be a little tiny delta here. That might be a delta. Nope. It's beta-gamma class. So yeah, not all that likely to produce large flares, in my opinion. And let's move on to meteorology. So we've got another atmospheric river showing up at California, as well as a strong low pressure system there off the west coast of the U.S. Here you can see that atmospheric river piping in some more Pacific moisture. That's the total cloud water from nullschool.net. And let's switch to our regularly scheduled meteorology there. The surface winds of the east and the jet streams. Jet streams of Europe, Africa, and the Middle East. And the surface winds of the Americas. And the jet streams. Jet stream still dipping very low, and a doubled up jet stream over North America. Next, clouds and fog. We show it daily as we zoom in closer and closer to the lower 48. So here is that moisture making its way from the Pacific across Baja California and now into California proper. As if there's not enough moisture in California already, and you can see that counterclockwise rotating low there off the coast of the northern portion of the state. Strong and large low there. Next, we're looking at the ozone layer. So if you're worried about a hole in the ozone layer, well, right here's one. There's an ozone hole. And of course, these are actually areas of higher ozone concentration. That's giving you some insight into what's going on in the stratosphere. The primary gas in the stratosphere is ozone, not to be confused with the surface ozone, which is a pollutant. The ozone layer, not the same thing. So that's a little bit of insight into what's going on in the stratosphere, folks. And let's move on to a thing. A thing at a place. Our weather.gov map. That's the thing. And there's the place. Weather.gov. Well, you got some freeze warnings there in parts of Florida, it looks like. Also some winter weather showing up in parts of the country. We'll show you some forecasts here. We scrolled down to show you the key. There's the full 50-state view. Weather.gov to see whether or not you've got weather warnings. Here is our GFS pressure and precipitation forecast for the next 72 hours. Oh, crap. I think I did a thing that I didn't mean to do. But, too bad, we're not going back. So, anyway, there's the GFS 72-hour pressure and precipitation forecast. Here is our total accumulated precipitation forecast in inches. And since some of that precipitation will be in the form of snow, here's your snow forecast in inches, your accumulated positive snow depth change for the next 72 hours, the GFS model. Next, the jet stream, and you can see it's, again, quite far south. The 250 millibar winds. And last but not least, the temperature anomaly forecast in degrees Celsius. So once again, it's a 72-hour GFS model. We'll move on to show lightning. Real-time lightning, courtesy of lightningmaps.org. What in the the hell is going on? Folks, we are experiencing some very strange technical difficulties. So, no idea what's going on with that. It's like my keyboard is not responding. Very strange. Anyway, let's close this thing out before I get enraged. There are the full 50 states. Here's the lower 48. Here is clouds and fog. Here is water vapor. Here's a recap. And here's me signing off. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.